Okay. So in graphs, what are we looking at? Real life graphs, such as travel graphs, conversion graphs, such as like exchange rate or something. Understand and use Cartesian coordinates, XY coordinates, how to plot the points on the graph, draw linear graph equations, straight lines. For straight line graphs, we use and interpret the gradient from the graph. That is, we'll be discussing formulas y2 minus y1 over x2 minus x1, gradient from coordinates of 2 points, length of line segment with the formula that is basically Pythagoras theorem, midpoint formula, equation of line y equals mx plus c. Then we have parallel and perpendicular line. Basically, we are covering coordinate geometry in this section. Understand the use of the fact that perpendicular distance from a point to a line is the shortest distance. This is always the shortest distance. If I say this is the wall AB and someone has to run from point X towards AB, so the shortest distance is not this. It is always perpendicular to the line. Draw and use and understand the graphs including functions of the form ax raised to power n, ab x plus c if like they are in power, x is in power form. And then sketches are part of syllabus, linear, quadratic, reciprocal, exponential graphs. And we will be discussing differentiation, that is not in depth, slight concept of differentiation for gradient. Now drawing linear graphs, you will be having an equation. For example, y is equals to 2x minus 3. That's a linear equation. How would you recognize it? The power of x is 1. So it would be a straight line. When you have power of x as 2, that's a single curve. And when you have power of x as 3, you have two curves. So for now, we're talking about the linear equation, and we can always have a table. It is not necessary that we make many values. Two are enough for straight line. For example, let's just ignore this part, and this is y is equals to 2x minus 3. Let me say I'm using x0. So when I substitute x0, I get minus 3. So one point is 0 comma minus 3. Now if I substitute, let's say x4, so y is equal to 2 into 4 minus 3 is 8 minus 3, that is 5. So x4 and y 5. So what happens is 0 comma minus 3 x0 y minus 3, this is the point, and then 4 comma 5 x4 y5, this is the point. Because it is a straight line, so these two are more than enough to draw the line. We would just use a ruler and pencil and draw the line. Sometimes it is the requirement of question to fill in the table. Mostly 90% of the values are already there, and we fill in the missing value. Worked example 2 says draw the graph of 3x plus 4y is equals to 24. In similar way is using 0 and 8. So if x is 0, this vanishes, and 24 by 4 is 6. So you got y6. When x is 8, 3 8 times is 24. It goes on the other side, so we get y as 0. So once done, we have two coordinates, x0, y6 and x8, y0. You just mark those 2 points and draw the straight line. Now there's an additional requirement. It says find a third point. Finding a third point is always advisable as check. Oh, okay. That's just a check, and definitely, yes, if you've not made any mistake, 2 are enough. So you may make a mistake. So it should be on straight line. Exercise 9.1a. For questions 1 to 10, draw the graph using the scale of 2 centimeters to 1 unit on x-axis. Now, what is this scale? Let's understand that. And let's try to make a grid. Okay. So it says for question 1 to 10, is this grid visible?
Yes, sir.
Okay.
It is visible.
So for question 1 to 10, draw the graph using the scale of 2 centimeters to represent 1 unit on x-axis. Basically, what you would see is if we have this grid, the grid is not there, 2 centimeters, 1 unit on x-axis. So let's say, if you're talking about this, let's say these boxes are 1 centimeter each, and 2 centimeters is 1 unit. So this is basically 1, this is 2, this is 3, and how what extent we have to draw would be given in the question. It says from -3 to 3. So this is -1, -2, and this is -3. So using a scale of 2 centimeter to 1 on x-axis done, and 1 centimeter to 1 unit on y-axis. So this is 1, this is 2, this is 3, this is 4, and -1, -2, -3, -4. Now the graph is 2x plus 1. And let's assume we are making no mistakes. So 2 points would be enough. I'm taking 0. You may take any points. So when x is 0, we substitute 2 into 0 plus 1, and I'm getting 1. And then let me say I take x1. So 2 into 1 plus 1. 2 1 times 2 plus 1 is 3. So at 1 it is 3. So basically x0, y1, and then x1, y3. Now I can use the straight edge and ruler, straight edge and pencil only to draw this line. Now this is more than enough, but sometimes from -3 to 3, we may need to draw the table like this: -3, -2, -1, 0, 1, 2, 3, and y. So we just got 1. At 1 it is 3, 5, 7. -1 is -1, -3, -5. So we can plot these values to get the straight line graph. Now this is something which is very much understandable with hands-on experience. Do you have any graph paper with you right now? Because the
Just
sketches
wait.
won't be
I
enough.
think I have. Let me check. I don't. But I don't have the other topics with you.
Okay. Meanwhile, just for the sake of visuals, I'll show you. We just did 2x plus 1. So if I type y is equals to 2x plus 1. So this is how it looks like. It passes through x0, y1, and on the other side, it passes through x negative 0.5. So it passes through x negative 0.5 and y0, and this is the like y-intercept and x-intercept. I don't have so much control on the software to change this 1 to 0.5 and this 2 to 1, like 2 centimeters and 1 unit. A written practice drawing of graphs is necessary for this section, this chapter. Okay. For each question from 11 to 16, draw the graph on the same set of axes and hence find the coordinates of the vertices of the polygon formed. Give the answers as accurately as your graph will allow. So now let's consider we are drawing this y is equals to x. I'll have to imagine at this time that y is equals to x. Now y is equal to x when x is 1, y is 1, x is 2, y is 2. So it would pass through the exact center. This is y is equals to x. Second says y is equals to 6 minus 2x. 6 minus 2x. Y is equal to 6 minus 2x. Y is equal to x. And the third one is y is equal to 4x. Okay, now y is equal to x is done. This is y is equal to 6 minus 2x. I can see that the gradient is negative. So the line is not in this direction, but in this direction. That's negative. And that's positive. So if x is 0, we can see that y is 6. Let's say 1, 2, 3, 4, 5, 6. And when x is 1, y is 4. So at x1, it is 1, 2, 3, 4. So we'll have that line drawn like this. Then the third one is y is equals to 4x. So x1, y4. So these were three lines, and we can see that we have 3 points of intersection 1, 2, and 3. And this particular polygon is known as triangle. And we need to write these coordinates 1, 2, and 3. Once this is drawn on a grid, which is marked, we will be able to write the exact coordinates. So I'm using the same software for now. This is y is equals to x, first line. Second is y is equals to 6 minus 2x. And the third one is y is equals to 4x. So we have these points of intersection, which is x1, y4, 1, comma 4. This is second one, x2, y2. And the third one is 0, comma 0. Getting it?
Yes, sir.
And I didn't take this into account because I was actually sketching. So once we are plotting, this is advised that we stay -1 and 3 because definitely beyond these limits, we will not be getting our answers. So we are preparing our Cartesian plane for x -1 to 3, -1 to 3, and y from -4 up to 14 for question 1. Exact similar way, question 12, 13, 14, 15. I'm just looking at them. And 15 is 4 equations. But all of them are definitely linear. Y is equal to 2x plus 7. Positive gradient, positive y-intercept. So let's make a sketch and then we will draw. So y is equal to 2x plus 7. I can see the gradient is positive and y-intercept is 7. Gradient is 2. Then I have x plus 4, y is equals to 10. When I make y the subject, this is minus x plus 10 over 4 over 4. So basically negative gradient, but 1 by 4. And the y-intercept is 2.5. So it should look like this, passing through 2.5 and negative gradient. Third line says y is equals to x. That was gradient 2. This is y is equals to x. And let me readjust the first one. when the gradient was 2, I'm making it a bit more steeper. And the last line says y is equals to 10 minus x. So at x 0, y is 10. I can see the y-intercept is 10 and gradient is minus 1. So let's say this is 10 and gradient is minus 1. So it should look like that. Let's just draw these lines. First one is y is equals to 2x plus 7. Y is equal to 2x plus 7. We have intercept at 7. Second is x plus 4y is equals to 10. When we make y the subject, we just got negative 1 by 4 gradient and 2.5 as y-intercept. So x plus 4y is equals to 10. See, 2.5 as y-intercept. And the third one is y is equals to x. And the fourth one, y is equals to 10 minus x. So this is how it looks like. If we are just talking about the 4 lines, this is our region. This is the region. Not this, because this is surrounded by 3 lines. This is the region which is surrounded by all 4 lines, and we would write these point of intersections. Clear?
Yes, sir.
Now these are all graphs. Let me take out a graph page and try question 17. Let's just use this grid as graph. It says for certain car, the equation connecting the annual distance traveled m kilometers and annual running cost c dollars as c is equals to m over 20 plus 200. Draw the graph for 0 to 10,000 using scale of 1 centimeter to 1,000 for m and 2 centimeters equals to $100 for c. So we are dealing from 0 to 10,000. So that means I need 10 centimeters. Let's say this is my origin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh, this is my 10. This is 1. And on y-axis, we have no such end till now. So I can see that when m is 0, c is 200. How are we getting these values? I'm substituting values in m. So when m is 0, c is 200. Let's say this is, or let me just get some values first, and then we'll decide the scale on y-axis. C is equals to m over 20 plus 200. So when m is 0, we have 200. Now be careful with what you use. 1 centimeter says 1000 kilometers. So basically when I'm using 1, I mean 1000. When I'm using 2, I mean 2000, and so on. So it says 2 centimeters. Oh yeah, scale is given. 2 centimeters, $100. So let's say this is 2, 100, another 2 is 200, and then 300, and then 400. So M kilometers and the annual running cost. So we just substitute and get the values. Let's say this is 2, 3, 4, 5, 6, 7, 8, 9. I can see that this is linear. Gradient is 1 by 20. I'm using 10, 10,000. So 10123 divided by 20 plus 200 is giving me a cost of 700. Hmm. Need some more writing space up till 700. So if that's 4, 5, 6, 1, 2, 3, 4, 5, 6, and 7. So when I substituted 10,000 in place of M, I'm getting 700. So at 10, this is 700. At 0, this is 200. So we have these 2 points. We can join them using a scale and few more points. Let's say at 5,000, 5,000 divided by 20 plus 200, I'm getting 450. So at 5, this is 400, this is 450. So we get the graph. Now it says from the graph, find the cost when the annual distance traveled is 7,200. So the distance traveled at the bottom, 7 is 7,000, 8 is 8,000, 7,200 would be two small boxes. We would have 10 boxes in between. So we'll just go up and see where it strikes and read it from the y-axis. I'm just checking by substituting this in the equation what I get. I'm getting 560. So when this is accurately drawn, we would definitely get 560. Till for now, I was getting a strike on 550. So it would be 560. And then it says the annual distance traveled corresponding to a cost of 320. So this is 3, this is 400, this is 350. So 1, 2, 3, 4. So 1, 2, 320. Against 320, we would just go and read whatever the value is. By calculation, I'm getting 2400, and from the graph, we should exactly get 2400. Okay. For today, we'll just stay within the graphs and let's practice some more. Which graph should we do? Of intersections without the graph page. Try this 10th, make a sketch and share the picture on WhatsApp. If you don't have graph paper right now, just use less details and draw this. Is it working, Aris?
Yes, sir, Ravi.
Mm. Y plus 3x is equals to 12, and we are doing this from minus 2 less than equal to x is less than equal to 4. I hope you would have done almost half by now.
Yes, sir, I am almost done.
I'm just punching these numbers in calculator. So we have our table from minus 2 to 4. Minus 2, minus 1, 0, 1, 2, 3, 4. And let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm taking this as 4, 4, 5. Let's say 5, 1, 2, 3, 2, 4, 6, 8, 10, 12, 14, 16, 18.
So I'm done.
Mm,
Let me set it.
yeah, sure, share it.
Oh, sweet. I need something more. Um, 6, 2, 18. Yes, now
This
I'm
is
set.
how it would look like.
Yes,
Negative 18 and y-intercept is 12 and x-intercept is 4.
yes, I'm sending you. So did you get?
Yeah, let me check. That's correct. We have intercept at 12 and we have intercept at 4. And this one mode is way better on Windows. You use this straight line or you do it?
I made it. Like when you hold it and it
Yeah.
correct itself.
It doesn't work like this on Mac. Okay. So more or less, this is it. It keeps repeating.
Mm.
So over the weekend, try not to do it in soft form, but on
In
hard page
on the
as
graph.
doing an exam.
Yes.
Use graph page, and one question out of these 10 would be enough, and one out of these would be enough. So make a choice of like, let's say the four equations. So 16, or let me choose it for you, and try 7. Okay,
Okay.
note that down.
7 and 16.
7, 16, and then the statement question. We just did 18.
Not 20.
You have the weekend, 19, 20. So total four questions. And please do them on graph paper, not soft form.
Yes.
And then we'll start coordinate geometry. We won't need any graph papers for that. Only this for today.